Now we are talking some of the topics under the file system. So in this file system we are going to see about the topic file system implementation. In file system implementation there are three approach: logical file system and file organization module, layered approach, and these three topics are discussed in file system implementation. So logical file system, the part of the file system that provides the interface between the user and the physical storage. It manages file metadata, directory structure, and file control blocks. File control blocks means we have already seen about the directory structure, which is root directory, user directory, or files and subdirectories are present in directory structures, and metadata in the sense it disk structure. So now we are going to talk about the new concept, which is file control blocks. File control blocks means a data structure that contains information about a file, including its attributes, location, and status. File organization module. In file organization module, translates logical file operations into physical storage operations. It handles the allocation and deallocation of space, mapping logical blocks to physical blocks. Free space management. Keeps track of free blocks on the storage device, ensuring efficient space utilization and allocation. So next we are going to, in layered approach, modern file systems often use a layered approach to separate different aspects of file management. This modular design makes it easier to implement, maintain, and enhance the file system. Layers typically include the application layer, logical file system, file organization module, and device drivers. These are all the layers which is present in the file system implementation. So all these topics are covered in this file system implementation. Then normal file can be implemented like this. Then next we are going to see about how directory can be implemented. Directory implementation. Linear list. Linear list is simple but inefficient method for managing directories, especially for large numbers of files. Each directory entry contains a file name and a pointer to the file's data blocks. Pros and cons of the linear list. Pros are simple to implement. Cons, slow search times as the list must be scanned linearly. Hash table. A most efficient method that uses the hash functions to map file names to directory entries. This significantly reduces search time by allowing directory access to the file entry. Pros: fast access times. Cons: potential for collisions, requiring collisions resolution techniques such as chaining or open addressing. Tree structure: a hierarchical structure that supports efficient searches, insertions, and deletions. Each directory entry can point to subdirectories, forming a tree-like organization. Pros and cons. Pros: scalable and efficient for large file systems. Cons: more complex to implement and manage. And now we are going to see about allocation methods. So continuous contiguous allocations. Contiguous allocation means each file occupies a contiguous set of blocks on the disk. This method is simple and provides fast access but can lead to fragmentation and resizing issues. Pros: simple and fast sequential access. Cons: fragmentation and difficulty in resizing files. Linked allocations. Each file in a linked list of disk blocks. The directory entry contains a pointer to the first block and each block contains a pointer to the next block. Pros: no fragmentation issues and flexible file sizes. Cons: slow access time due to the need to follow pointers and additional storage overhead for pointers. Indexed allocation. Uses an index block to keep track of all the blocks allocated to a file. The index block contains pointers to the data blocks allowing direct access. Pros and cons. Direct access to blocks and efficient for random access. Cons. Overhead of maintaining index blocks.